Okay, this is 5.5, 242 in your textbook. The only difference between today's lesson and yesterday's lesson, the only difference is this. It's the a value in front of x squared. Okay, so we call this the coefficient of the x squared term. That's the only difference. Okay, we're still doing factoring, but the only difference is that we have a value there. Okay, this value complicates things for us. It'd be nice if this value wasn't there, because as you saw yesterday, when this value wasn't there, we could go straight to two sets of brackets, find those two numbers, and we were finished. Okay, unfortunately, it's not so for today. So the first thing I do want you guys to be accustomed to doing or get in the habit of doing is seeing if you can factor this out. Okay? Seeing if you can get rid of this term. So if I have a term like this, okay, let me just show you this example in the center. The first thing you should notice is that the 3 is common in all three terms. So you want to try and factor that out first. So you divide 3 from each term. Okay, anybody confused what I did there, how I changed that from there to there? No. Now that I've done that, I can factor just this term. I'll leave the 3 alone, and I can factor just this term. Okay, I do M and A for that term. All right, so that's the idea. We always want to try and do that because it simplifies the problem. However, there are cases where you cannot factor out the first term, such as this. 3 doesn't go into 8 or 4. So we have to deal with it. Okay, and that's what today's lesson is about. Is what do we do when we have a value, an a term? Okay, so the first thing we do is the same step as before. We can't factor this out, but we are still going to do M and A. Okay, what multiplies now, and I talked about this yesterday, and I was always using 1 here, because the a term was always 1. But I was still showing you guys that I was actually multiplying this term times this term. So what multiplies to give me 3 times 4 multiplies to 12. And then adds is still the center term, which is 8. Okay, so it's the same process. It's the first coefficient times the last coefficient, or constant. So it's 12 and adds to give me 8. So the two numbers, some people might know right away, but if you're not sure what they are, you start off by dividing the 12 by 1, and then looking at the last 2 terms of that division and seeing if they can make 8. They cannot, so I'm going to divide by 2. So now I have 2 and 6. Positive 2 plus positive 6 equals positive 8. And I'm also looking for positive 12. Positive 2 times positive 6 is positive 12. So my two numbers are 2 and 6. So now, rather than going to 2 sets of brackets and putting 2 and 6 in, I can't do that anymore. I have to instead break up this center term in terms of those two numbers, 2 and 6. So instead of 8x, it's going to be plus 2x plus 6x, and I leave the 4 on the end. Okay? So see this term, we call it decomposition because the center term has been decomposed into these two terms. Okay? Notice also that I have not changed the equation. The equation is still the same. I've just expanded that 8x. Okay? Very specifically though, remember I've only chosen 2 and 6. I can't just choose 4x and 4x. It has to be those specific numbers because they have to line up with M and A. Any questions to there so far? Yeah, Jessica.
So the m, do you get the m from multiplying the coefficient of x squared and the last number?
Yes, the first number and the last number. Okay? And it was the same yesterday except for a was always 1, so we were just looking at the last number. Okay, because it was always 1 times the last number. Okay? But also be aware of these signs. This is positive times a positive is a positive, and this sign is positive, so that's positive. Okay, it'll come into play as we see negatives over here and here. Okay? Any other questions? All right, so now that I've decomposed it, it doesn't matter if I would have wrote the 6 first or the 2 first. That doesn't matter. Okay, as long as they added up to 8, that's fine. Now, from what you guys have already learned, you're going to factor partial factors. So you're going to factor these two terms and these two terms. All right? So So these two terms factored. The only thing in common between these two terms, David, is what? What can I factor to these two terms?
The x.
Good, just the x, right? And what am I left with?
2.
This term and this term?
3.
Let him think, guys. Yeah? 3x squared divided by x?
Is 3.
3x squared divided by x?
3x.
Good, 3x. And then 2x divided by x?
2.
Good, plus 2. Okay, now you're going to factor these two separately. So what's common between these two?
2.
Good, so plus 2. And what's left?
3x. And
Yeah.
2.
Plus 2. Okay, and now you guys can see that I've done it correctly. You should always, I'm going to say it again, always have these two terms be the same, these two binomials. That's how you know you did it right. If you didn't end up with these two the same, you did something wrong. So now I just fill in factoring out the binomial, 3x plus 2, and what I'm left with, I divide this by 3x plus 2, I'm left with x, and divide this, I'm left with plus 2. And that's my final answer.
Wait, what?
I'm going to write this a bit lower so you guys can see this better. Okay, I heard a lot of what's, so please ask me. This step was confusing to people. Yeah, Gianluca?
What did you just do?
Okay, so notice how, Gianluca, there's this term here and this term, they're the same, right? Okay, so just as if they were an x, I factored them out. Okay, so I said this term is common, I'm going to put this term here. Okay, and now I'm going to divide each term by 3x plus 2. So x times 3x plus 2, these cross out, I'm left with x. 3x plus 2, these terms cross out, I'm left with 2. Okay? Any other questions there? And this should be reviewed from 5.2, I believe. Okay? Factor by grouping. You guys remember that? We did factor binomials out. Alright, next question. 3x squared plus 2x plus 4. The first thing I notice, I have an a value. I cannot go to two sets of brackets right away. It's unfortunate, but I can't. I also cannot factor out the 3. So I need to deal with it. So I do m and a. M is 3 times 4 again is 12. And a this time is 2. Okay? You might know the numbers right away. You might not. Yeah?
So isn't a 4 the last number?
Yeah. So it's going to be adding to the center number always.
Oh, yeah.
Multiplied to the last two numbers. Okay? So let's go ahead and divide by 1 is 12. Can I use these numbers to make 2? No. Can I use these two numbers to make 2? No. Can I use these two numbers to make 2? No. Can I use these two? No. So there's no two numbers that I can use. Yeah, Steve?
Sure. Aren't you supposed to do 3x times x and then 3x times 2?
No. This term times this term. First term
no,
times...
all the way at the top before you got, how you got that. No, like equals like 3x, when you got from there to there.
I didn't. This is a new question. See? This is B.
Oh, okay. I was confused.
Okay? Everyone else understood that? Okay. So in this case, guys, there's no two numbers that I can find out that multiply to 12 but add to 2. So in this case, and I'm going to tell you it's a rare case, but it does happen, you're going to write cannot factor. Okay? Any questions? Alright, so when we have that scenario where we can't find two numbers that add to 2, then you cannot factor. Okay? Next one. So let's see. So here, again, I have a value in front of x. I can't go to two sets of brackets. I also cannot factor it out. So I have to deal with it. I have to do what's called decomposition, m and a. So m is 6 times 1 is positive 6, and a is negative 5. Alright, so in this case, you're going to divide by 1 is 6. Can I somehow use these to make this?
Yeah.
I can, yeah. This has to be negative 6 though, and that positive 1. Those will add to give me negative 5, but they will not multiply to give me positive 6. So I can't use those, can I? No, so those numbers, this is the first time where we've seen two numbers that can add to negative 5, but cannot multiply to positive 6. Okay, so these numbers do not work. So this so far has been the trickiest question. Because we've got two numbers that we can add to negative 5, but when we multiply them, we cannot get to positive 6. So I have to keep going. Divided by 2 this time, and 3. Well, look at that. I got two numbers again that can add to 5. But this time, yeah, Luigi?
Negative 2 minus 3?
Yes, this time if they're both negative, they can multiply to positive 6. You see that? So in this scenario then, negative 2 and negative 3 are my numbers. So I need to decompose that middle term to negative 3x and negative 2x plus 1. Again, it doesn't matter which one you put first. If I reverse these, it'll still work out. Okay? So now we're going to partial factor. We factor these two terms. We have 3x. 6x squared divided by 3x is 2x, and then minus 1. In this case, there's nothing in common, but I do need to factor out that negative 1. If there's nothing in common when you're partial factoring, you always factor out the 1. Okay, in this case, it's negative 1. I'm going to do 2x minus 1. See how those two binomials are the same? So that's my final answer. I factor this out now. What I'm left with is 3x minus 1. Any questions? Sebastian?
What would you do if it was positive 2x?
If it was positive 2x here,
Yeah.
then it wouldn't have worked out. So these numbers would have been wrong.
Yeah.
Okay? Remember, guys, you're creating this. Up to this, you're choosing these numbers, so it should always work from here on. As long as you chose those two numbers correctly, it should work. You should never get stumped after that. The only time you can say it's not factorable if you cannot get these numbers. Connor?
So, the second in the brackets in the final answer is always the...
Here?
The second group.
Here?
No,
3x.
that one,
Yeah.
It's always those two.
Yes.
Okay.
Because what you're doing, Connor, is you're taking this term, 2x minus 1, and you're factoring it out. So that means you're dividing both these terms by 2x minus 1. So you're left with 3x minus 1, because the 2x minus 1 cancels. Okay? All right. Next one, we just have another variable. Doesn't change the process. Process is the same. We look to see if we can factor anything out. We cannot, unfortunately. We still have an a value, so we do m and a. Here our numbers are a bit bigger. We have negative 40, and we have to add to negative 3. Okay, so some of you might know these two numbers that multiply to negative 40 but add to give you negative 3. But if not, you're going to go ahead and just divide by 1. 40, so I'm nowhere close to this, so I can keep going. 20, still nowhere close. Divided by 3 is not an even number. Divided by 4 is 10. So now I'm down to 6. Still got to get to 3. Divided by 5 is 8. So 5 and 8, in some combination I can make 3. So I need to make 8, negative 8, and positive 5, and they multiply to negative 40. So those are my numbers then. So I have 10x squared, I leave the first term alone, minus 8xy now, because the middle term has a y variable, and then plus 5xy, and my last term stays the same. Any questions there? Yeah?
Does it matter if the 8 or the 5 was negative or positive? Did you switch it around?
No, the sign does matter, yes.
So it could
Because if I put 5 positive, if I put 5 negative and 8 positive, then I would be adding to positive 3. Okay? But it doesn't matter which one you put first. Okay? So I could have done 10x squared plus 5xy minus 8xy. But the signs do matter. Okay? Any questions to there? Now I go ahead and partial factor. So what's common, Daniel, between these two?
X.
The great, yeah, what else?
Or 2.
Good, 2x, good. And what are you left with?
You're left with
5x
Good.
and 4xy.
Positive or negative?
Negative.
Negative 4. Look at it again. 8xy divided by 2x.
Negative 4x.
No, because the x's cancel, right?
Y.
Good. Okay, and then what's common between these two?
Nothing.
Why?
No, the y, right? So it's going to be positive y. And what are you left with?
5x.
Yeah?
And then negative 4y.
Good. And you always want these two to be the same, right? You know you've done it right, if that's the case. So the last step, you factor out this binomial and whatever you're left with. Okay? Any questions there? Yeah, Julie.
How come the y is positive? Can it be like a negative y?
Here?
Yeah.
Because I want to have the exact same binomial here. It's usually always you want the first term positive. Almost always. Okay? So if this was negative, I would have done negative y. Okay, so you're always in agreement with this term. Okay? Alright, over here. Who wants to try this one? Michael, yeah. Excellent. So he noticed right away that there's something in common between these three terms. So he wants to factor this, so he wants to lower it. Okay, he wants to lower these numbers. So what's common? 2, good. So he's going to factor out the 2 and you're left with what?
8x squared
Yeah?
plus 13x minus 17.
Excellent. Okay, that makes his job a lot easier. Okay, so you always want to look for a common factor before you start. But now we still have an a value, so we can't go to 2 sets of brackets right away, unfortunately. We still need to have to do m and a. We're going to ignore the 2 for now. We're just going to leave the 2 on the outside. And we're going to go ahead and decompose this middle term to these two numbers. So 8 times negative 6 is negative 48. And add to positive 13. So numbers are getting a little trickier. So if we don't know the number, we can divide by 1. 48, nowhere close. Divide by 2 is 24, nowhere close. Divide by 3 is an odd number, I believe. Oh, it's 16? Sorry. 16 works, right? 16 and 3? So in this case, because the 13 is positive, we want it to be positive 16 and negative 3. So positive 16x. Okay, so notice again on every single time that this middle term has just been broken up into 2 numbers, but it has not been changed. Okay, 2 plus 6 is 8. Negative 8 plus 5 is negative 3. And 16 minus 3 is 13. All right, now that I have it broken up, I can partial factor. So what's common between these two, Michael?
8x.
8x, and what am I left with?
2x squared. I mean, no,
X
plus 2.
plus 2, and then what's common between these two?
Negative 3.
Yep, and
X plus 2.
okay, still leaving the 2 on the outside. Now I common factor the binomial. Any questions there? Any questions? No? All right, so to summarize, you're always going to look for a common factor first. You're going to look for the a value, see if there's a common factor. Next, to factor, you're going to find 2 integers whose product or who multiply. A times c, so that's the first coefficient times the last. Then break up the middle term and factor by grouping. So you break up the middle term into those 2 numbers that multiply to give you the AC value and add to give you the B value. and then you factor by